Hey everyone, so today we're going to go over acceleration and velocity, and we're going to go over some formulas before we can get into the problems. So the formula for velocity is equal to displacement over time. Now you may be asking yourself what displacement is, but displacement is simply the change in position. So we can calculate displacement by getting the final position and subtracting it from the initial position. So knowing that, we can say that velocity is equal to xf, which is the final x position, minus xi over time. Now that we have the formula for velocity, we need to get the formula for acceleration. Now the formula for acceleration is equal to the change in velocity over time. So vf minus vi over time. Now knowing this, it's important to know that speed and velocity are different. Speed is how fast distance is changing, and velocity is how fast displacement is changing. It's different. Speed cannot be negative. Velocity can be negative. And then acceleration is how fast the velocity is changing. Now, acceleration and velocity are vectors, so they can be positive and negative. Speed is a scalar quantity. It can only be positive. So knowing that, let's do our first question. A car accelerates from 20 meters per second to 40 meters per second in 10 seconds. What is the average acceleration of the car? So let's whip out our formula. A is equal to Vf minus Vi over time. Now, before we do that, actually, let's write out our givens. Our Vf is equal to 40 meters per second. Our Vi is equal to 20 meters per second. And our time is equal to 10 seconds. Let's get back to the formula. A is equal to 40 meters per second minus 20 meters per second all over 10 seconds. Therefore, A is equal to 20 on top divided by 10. A is equal to 2 meters per second squared. As you can see, it's not too difficult. Let's try the next question. A train accelerates from 30 kilometers an hour to 70 kilometers an hour in 25 seconds. What is the average acceleration of the train? So a similar style question. First, let's write out our given. Our Vf is equal to 70 kilometers an hour. Our Vi is equal to 30 kilometers an hour. And our t is equal to 25 seconds. And we're looking for A. Now let's whip out our formula. A is equal to Vf minus Vi over time. A is equal, acceleration is equal to 70 kilometers an hour minus 30 kilometers an hour all over 25 seconds. Acceleration is equal to 40 on the top. 40 divided by 25 is equal to 1.6 meters per second squared. Now, our acceleration of the train is 1.6 meters per second squared. Let's go to the next problem. A bus accelerates from rest at a constant rate of 4.8 meters per second squared. What is the speed of the bus 15 seconds later? So let's write out our given. We have our acceleration, which is equal to 4.8 meters per second squared. We have our time, which is equal to 15 seconds. We have that the bus accelerates from rest, which means our Vi is equal to 0 meters per second. And then we're looking for our Vf. So let's use the same formula we used earlier. Acceleration is equal to VF minus VI over time. But now we want to isolate for VF. So we can multiply by time on the bottom, multiply by time over here, and we'll be given AT is equal to VF minus VI. VI is 0, so minus 0 doesn't really matter. So AT is equal to VF. Acceleration times time is equal to VF. So when we plug this in, we get 4.8 meters per second squared times 15 seconds is equal to VF. And the answer is 72 meters per second is equal to VF. So after 15 seconds of accelerating at 4.8 meters per second squared, the speed of the bus is 72 meters per second. That's a really fast bus. Now for the last problem, a quad is traveling at 25 meters per second and it slams the brakes and reaches a stop in 3 seconds. What was the average acceleration of the quad? So let's write out our given. Our VI is equal to 25 meters per second. Our VF is equal to 0 meters per second since it comes to a stop. Our time is equal to 3 seconds. And our acceleration is what we are looking for. So A is equal to VF minus VI over T. A is equal to 0 minus 25 meters per second over 3 seconds. A is equal to negative 8.3 meters per second squared. Now, since acceleration is a vector, it can be negative, but let's try and make sense of this. If something is moving forward and it has to come to a stop, the force is going to be in the opposite direction, which is why the acceleration is negative 8.3 meters per second. So yeah, that's all for today. I'll see you guys next time.